So, let's talk about copper. It was the very first metal humanity ever got the hang of. But what's really cool is that this isn't just some simple timeline. No, it's actually this incredible tale of two totally separate worlds an ocean apart that both figured out the secrets of this amazing material. But, and this is the key, they took it in completely different directions.
For thousands and thousands of years, everything we made was defined by stone. That was it. But copper changed everything. It was like the bridge that got us out of the Stone Age. It set us on a course for all the complex metalworking that came later. And it wasn't just about having a new shiny thing to work with. It was a totally new way of thinking about how the world worked.
And yeah, this really shows you what I mean by that mental shift. On the one hand, you've got stone. For all of human history up to that point, the only thing you could do was subtract. You take a rock and just chip pieces away from it, right? It's brittle, you can only take away. But then, boom, copper comes along. You could hit it, and guess what? It didn't shatter. It bent. It stretched. It changed its shape. This was a brand new concept, plastic deformation. It was formative, not subtractive. And that just blew the doors open on what was possible.
Okay, so our story begins in the ancient Near East. Imagine you're a Neolithic person, and you stumble across this weird reddish stone that acts like nothing you've ever seen before. We're talking about a place called Chayanu Tepe in what's now Turkey. And we're going way back, like 11,000 years ago. People there were finding these chunks of what we call native copper, basically pure metal just sitting right on the surface. And at first, they weren't making weapons or tools. Nah, they were just cold hammering this stuff into these simple, beautiful things, beads, pins, little decorations.
But here's where it gets really interesting. They didn't just stop at hammering it. The people at Chayonu figured something out, a secret that would literally shape the next few thousand years of history. They learned how to combine this new redstone with humanity's oldest and most powerful tool, fire. And that secret, it's called annealing. See, here's the thing with copper. The more you hammer it, the harder it gets, but it also gets really brittle. If you just keep going, it'll crack and break. But somehow, these ancient craftspeople figured out that if you gently heat the metal up and then let it cool down, it gets soft and easy to work with again. It's amazing. And we know they did this because when we analyze those tiny artifacts from Chayonu, the evidence is clear. They totally mastered this really sophisticated process way earlier than we ever thought.
So this is basically the cycle. You hammer the copper, right? And you're messing up its internal crystal structure. Then you add some heat, and that lets all those crystals kind of relax and line up again. Once it cools, boom, the metal is good as new, ready for you to work on it some more. This was so much more than just metalworking. This was the birth of what we call pyrotechnology, using fire on purpose to change what a material can do.
You can't overstate how huge this was. Once they understood that fire could transform copper, that was the first major intellectual leap. That's the idea that eventually leads to smelting, pulling metal out of ore. That one little discovery, right there in the Anatolian highlands, it basically laid all the groundwork for what would become the Bronze Age.
All right, now I want you to completely shift gears. We're going to travel thousands of miles away, all the way over to North America. Because over there in the Great Lakes region, a totally separate copper revolution was happening. And this one was driven by a very special gift from the Earth itself. So the area around Lake Superior, it just so happens to have the biggest and purest deposits of native copper on the entire planet. We are talking about giant veins of metal that are over 99% pure. You could often just find it right on the surface. You didn't need to dig it out of ore or anything like that. It was just there, a gift from the landscape. And the people there, the cultures we call the Old Copper Complex, they became absolute masters of this stuff. But here's a key difference from the Near East. Their focus was super practical. They made this incredible advanced toolkit. Socketed spear points, heavy adzes for cutting down trees, super sharp knives, fish hooks, harpoons, the works. And get this, these weren't just stone tools copied in metal. No way. These were brand new, sophisticated designs that took full advantage of what only copper could do. Okay, so here's the big puzzle. Just like the people back in Chayonu, these artisans in North America figured out annealing all on their own. They totally got how to use fire to make the metal workable again. And yet, for the thousands of years they used copper, they never, ever developed smelting or casting. So why?
Why did this amazing technological journey seem to just stop there?
Well, the answer isn't that they failed. It's actually just logic. This wasn't some technological dead end. It was a perfect adaptation to their world. Think about it. Smelting is a really hard, fuel-intensive process that you only need if you have to get your metal out of ore. If you have a nearly endless supply of 99% pure metal just lying on the ground, why on earth would you invent a super complicated, difficult process you have absolutely no need for? The pressure to do so, socially or economically, just wasn't there.
So what we're left with are these two incredible parallel stories. You've got two completely independent hubs of innovation, both mastering the world's first metal. But because of their unique situations, they end up heading in totally different directions.
And look at the comparison. The timelines are pretty similar, right? But the differences are just stark. Over in the Near East, you have less pure copper mixed with ore, and that pushes them towards making ornaments, and that path eventually leads them to figure out smelting. But then in North America, you have this crazy abundance of pure copper, and that leads to a culture focused on making seriously functional tools with a technology that was a perfect match for that resource. It's the same metal, the same core technique, annealing, but the results could not be more different.
So what's the big takeaway here? What does this tale of two coppers really tell us? Well, it kind of throws a wrench in one of our most basic ideas about how history is supposed to work.
We love to think of technology as this ladder we're all climbing, you know? A straight line where every step is higher and better than the one before it. But the story of copper just shows us that's not right. It's not a ladder. It's more like a branching tree. A new technology isn't automatically better or worse than what came before it. It's an adaptation. And the path it takes is shaped by everything. The geology under your feet, the environment around you, and what your society actually needs.
So, how in the world did our ancestors look at a plain green rock and figure out how to turn it into metal? I mean, it's not exactly intuitive, is it? This is a genuine mystery.
But before we can even get to where this all started, we first have to understand the breakthrough that made everything else possible. And that breakthrough is called smelting.
Now, this wasn't just about, making rocks really, really hot. Smelting is a pretty complex chemical reaction. You need incredible heat, sure, but you also need a low oxygen environment. That's what actually strips the oxygen atoms away from the metal inside the ore. Mastering this was the key that unlocked a massive new resource for humanity.
And just to put this into perspective, the leap was just enormous. Before this, pure copper was this super rare thing you might get lucky and find lying around, a neat curiosity. But after smelting, it became a material you could mass produce from mountains of rock, enough to build entire civilizations with.
For the longest time, archaeologists had a very neat and simple story about where this all began. A story that, well, turns out it was just plain wrong.
You see, the old theory was that metallurgy was invented one time, and one time only, somewhere in the Near East. And from there, this light of knowledge slowly spread out across the rest of the world, a single spark of genius. But yeah, new evidence shows that's not what happened at all. Because some incredible discoveries in a totally different part of the world have completely shattered that old way of thinking. Get this, it turns out the earliest, most solid evidence we have for copper smelting wasn't found in the Near East. Nope, it was discovered in the Balkans, in modern-day Serbia, and it dates back a staggering 7,000 years, all the way to 5000 BC.
The culture that got there first was the Vinca. And these people weren't just making advanced pottery. They were becoming pioneers of a brand new, fire-based technology that would completely change the course of human history.
And the proof was just undeniable. Archaeologists found slag. That's the glassy waste that proves smelting was happening. They found the raw malachite ore they were using. And they even found furnaces that could get up to the crazy hot 1100 degrees Celsius needed to do the job. This wasn't just a one-time fluke. This was a real, sophisticated, consistent technology. And when you put it on a timeline, it's just crystal clear. The Balkan sites are centuries, maybe even a full 1,000 years older than the places we used to think were the origin points. By the time this advanced metalworking shows up in the Levant, the Vinca culture had been mining and smelting copper for generations.
So this just flips the whole story on its head. And it raises this massive question. If the Vinca invented smelting all by themselves, how on earth did they figure it out?
Seriously, think about it for a second. It seems impossible. You can't just look at a green stone and think, I bet there's shiny red metal inside if I cook it.
The leading theory is that it wasn't some moment of brilliant insight. It was actually a very, very lucky accident.
The most likely story is actually kind of amazing. So for about 1,000 years, the Vinca had been using this green malachite rock as a pigment, for decorations and paint. Then, one day, some of that crushed up green powder probably just fell into a pottery kiln. A kiln that just happened to have those perfect high-heat, low-oxygen conditions. And an observant potter would have pulled out their pottery and seen these weird, shiny little red beads in the ash. And that's when they made the connection. Green stone plus a whole lot of fire equals red metal. And just like that, history was changed forever.
And this one invention, it didn't just stop with copper. It sent ripples out that led to even more advanced technologies and some absolutely breathtaking works of art. Once the technology spread, artisans just started producing these staggering works. A perfect example is this hoard of stuff found in a cave in the Judean desert. I mean, over 400 copper objects. And we're not talking simple tools. We're talking about incredibly intricate crowns and ceremonial maces. Copper had gone from just being useful to being this high-status ritual art form.
And the complexity of these objects proves that metallurgists had mastered some incredibly advanced techniques, like lost wax casting. This isn't something you can do by just hammering out a piece of metal. It takes a deep understanding of how the material works, and a really sophisticated multi-step process.
Right, so this is where the story takes another fascinating twist. The invention of the next great material, iron, wasn't some totally separate discovery. It was actually a direct result of people trying to get better at making copper.
So these early smelters had a problem they needed to solve: how to get the molten copper to separate from all the other worthless melted rock. They discovered that if they added other minerals, what's known as a flux, it helped. And one of the most common and effective things they used as a flux was iron ore. It was just a little chemical trick to get more copper, but it had this incredible unintended side effect.
And this right here, this is the punchline. In the intense heat of those copper furnaces, the iron oxide they were adding as a flux could itself accidentally turn into metallic iron. So in their quest to make better copper, they inadvertently discovered the metal that would define the entire next age of humanity.
Today, we're going on a journey way back in time. We're gonna uncover the story of a single metal alloy that didn't just build swords and shields, it literally constructed our first truly interconnected world.
And it all really kicks off with this one question. You see, the hunt for a stronger weapon, for an edge on the battlefield, well, it started a chain reaction that would stretch across entire continents. It would build empires, and in the end, it would reveal a kind of fragility that feels, well, incredibly familiar today. So let's dive in.
Okay, so our story starts with copper. For early civilizations, this stuff was a game changer. It was shiny, you could shape it, it was amazing. But it had one massive flaw. I mean, it looks great, for sure. But pure copper, it just wasn't tough enough. If you made an axe out of it, the edge would dull almost instantly. A sword would bend in a fight. It was a status symbol, yeah, but it couldn't be the foundation for an army or a farm. This one problem, its softness, sent the ancient world on a desperate search for something better, something much, much stronger. The first real breakthrough was probably a complete accident. It was a dirty, dangerous, and pretty deadly discovery that created a new metal alloy, one that was harder than copper, but it came at a terrible, terrible human cost. And this stuff was called arsenical bronze. You see, some copper ores just naturally have arsenic mixed in with them, and when you smelt those ores down, you get a metal that's way harder and a lot easier to cast. It was the upgrade everyone was looking for. The only problem? It had a hidden, lethal secret.
And here's what's so terrifying about it. When they smelted this ore, it released arsenic fumes. But these fumes were invisible. They had no smell, no taste. So the smiths would just breathe this stuff in, day after day. It would lead to chronic poisoning, nerve damage, horrible skin problems, and eventually, a very distinct limp before it killed them.
And you can actually see the memory of this human cost baked right into their mythology. Think about Hephaestus, right? The Greek god of blacksmiths, always shown with a limp. A lot of historians think this isn't just a random detail. They believe he's a mythological echo of the very real, crippling dangers that came with making the world's first super alloy. So obviously, they needed a better way, something that wouldn't kill the people making it. And that search led them to tin. Mixing tin with copper created a fantastic bronze, and with none of the poison. But in solving one huge problem, humanity stumbled into a brand new one, a massive geopolitical paradox of scarcity. Okay, so here's the fundamental problem, the big paradox. Copper ore, well, it's pretty common. You can find it all over the place. But tin? Tin is geologically super rare. So you have these massive empires in the Near East and the Mediterranean, the biggest customers for bronze. And they're practically swimming in copper, but they have zero tin, none. So where on earth did they find it? Well, the answers are kind of shocking. We're talking about mines in places like modern-day Afghanistan and Uzbekistan, the Taurus Mountains over in Turkey, and, get this, all the way over in Cornwall at the southwestern tip of Britain. And just like that, making the most important material on the planet was no longer a local backyard operation. It went global. To get the tin they were so desperate for, these ancient empires had to build and maintain these huge, complex, and unbelievably long trade routes. These were the first true global supply chains in human history. It's honestly hard to wrap your head around the sheer scale of this thing. But lucky for us, we have the 3,300-year-old time capsule discovered at the bottom of the Mediterranean Sea. That gives us this perfect, crystal-clear snapshot of exactly how it all worked. Say hello to the Ulu Boron shipwreck. This single trading ship sank around 1300 BC, and its cargo was just mind-blowing. It was carrying 10 tons of copper ingots from the island of Cyprus. And right alongside it was 1 ton of tin, which we now know from chemical analysis came all the way from Central Asia and Turkey. And here's the part that'll give you goosebumps. That ratio of copper to tin on the ship, it wasn't an accident. It was the precise 10-to-1 recipe needed to forge 11 tons of perfect, high-grade bronze. This wasn't just random trade, no way. This was like a floating, pre-packaged industrial kit. It's a snapshot of a sophisticated, calculated global industry. So who was running this whole show? Well, the ship's cargo tells a pretty clear story. While the big empires like Egypt and the kingdoms of Mesopotamia were the major customers, the undisputed king of production was Cyprus, which they called Alashia back then. This one small island was the engine room of the whole operation, mining, smelting, and shipping out the metal that fueled the entire Bronze Age. For hundreds of years, this incredible system of mines and ships and trade routes actually worked. It built palaces, it equipped armies, but when you build something that big, that interconnected, it also becomes incredibly fragile. And it was all about to come crashing down. And then, around 1200 BC, the bottom just fell out. Historians call it the Late Bronze Age collapse. It was a time when entire empires fell, major cities were burned to the ground, and that complex web of trade that held their world together just unraveled. So put yourself in their shoes. The world is collapsing. The trade routes are dead. It all boils down to one terrifying question. What do you do when the tin just stops showing up? Well, you get something called a tin famine, and it's exactly what it sounds like. The most critical, strategic resource for your entire civilization, gone. Vanished. Without tin, you just can't make bronze anymore. The engine of their world had lost its most important part, and that crisis forced them to pivot to a brand new material. And that new material was iron. But here's the kicker. Early iron wasn't actually better than good bronze. In fact, it was softer. So why switch? Well, iron had one superpower: availability. Iron ore is literally everywhere. Its greatest advantage was that you didn't need a global supply chain to get it. The collapse of the world forced technology to become local again. But, even in all that chaos, the story doesn't end there. The real experts, the masters of metal on Cyprus, they found a way to survive. The archaeology shows that while the world around them was burning, the Cypriot cities actually ramped up their copper production. They weathered the storm and reinvented themselves, selling their core product to a brand new Iron Age.
Today, we are diving into a story about industrial power, but one that happened almost 2,000 years before the Industrial Revolution even started. We're talking about the Roman Empire and its absolutely insatiable hunger for copper. And believe me, the scale of their operation is just, well, it's gonna blow your mind. Let's dig in. But hey, before we get into the heavy machinery, a quick question for you. If you ever look at a periodic table, you'll see copper's symbol is Cu. Kind of weird, right? It doesn't sound anything like the English word. So, any idea where it comes from? Yep, you guessed it. The answer goes all the way back to the Romans.
You see, the Romans originally called it As Cyprium, which literally meant metal from Cyprus, because that island was just loaded with copper mines.
Well, over time, that got shortened to just cyprium. And then that name kind of morphed into cuprum. And from cuprum, bam, we get both our chemical symbol, Cu, and our modern word, copper. It's a little piece of the Roman Empire hiding in plain sight in every science classroom.
So, that's a cool little language connection for sure, but it brings up a much bigger question. I mean, the Romans were the Iron Age empire. So why on earth were they so obsessed with a metal from the Bronze Age? What made copper so important that they'd go to such incredible lengths to get it?
Well, the thing is, copper was literally woven into the fabric of Roman life. Sure, it wasn't the top metal for weapons anymore, but it was absolutely essential for the economy. We're talking about coins, like the famous sestertius, which were all made from copper alloys. Not to mention the grand statues, all the plumbing, and the creation of a brand new golden-colored metal called brass. All of it, every last bit, depended on a huge, steady supply of copper.
And the heart of this whole massive operation was in what we now call Spain, at the mines of Rio Tinto. After the Romans took the area from Carthage, they brought their military-level engineering skills to the world of mining. But it wasn't a walk in the park. Oh no. They ran into two absolutely enormous challenges that would push their famous ingenuity to its absolute limits.
And this slide right here, it perfectly lays out the two core problems that drive our whole story. First, you've got a physical problem. As they dug deeper and deeper, the mines were constantly flooding. So how do you get water out of a hole that's hundreds of feet deep using nothing but muscle power? And second, a chemical problem. The best ore was deep down, and it was a type called sulfide ore, which holds onto its copper with a chemical death grip. It's incredibly stubborn stuff.
So let's look at that water problem first. On the surface, the Romans found a way to turn water from an enemy into an incredibly powerful weapon. Their solution was just pure, unadulterated brute force, on a scale that literally changed the landscape.
The Roman writer Pliny the Elder actually described this technique. He called it ruina montium, which means the wrecking of mountains. And that's exactly what it was. As you can see here, they would build these huge reservoirs and aqueducts high above the mine. Then they'd channel all that water into tunnels that cut into the rock. And when they finally unleashed it, the hydraulic pressure was so immense it would fracture and just wash away entire hillsides, exposing the precious ore veins underneath. It was basically terraforming with an industrial purpose.
But remember, that trick only worked for removing rock on the outside. Deep down in the mine shafts themselves, the constant seeping of groundwater was a relentless, quiet enemy, always threatening to flood the lower levels and stop all the work. Down there, you couldn't use brute force. Down there, you needed a machine.
And wow, what a machine it was. Archaeologists at Rio Tinto actually found the remains of this incredible system. We're talking about a series of 16 reverse overshot water wheels. Now, these weren't powered by the water. Their job was to lift the water. They were set up in pairs, forming a kind of cascade. Each pair would lift water up to the next one, raising it over 30 meters, that's almost 100 feet, out of the mine. And for good measure, they used Archimedes screws to move huge volumes of water too. It was an entire underground factory powered by nothing but human.
And this is where the story takes a dark turn. It's where that engineering brilliance slams into a brutal, terrible reality. Because who do you think was powering those machines? It was enslaved people. Men forced to walk on treadmills in the damp, perpetual darkness, endlessly cranking these wheels. Every single Roman coin, every bronze statue, it all carried a hidden, terrible cost, paid for by immense human suffering.
So with the water problem, well, let's say managed, they still had that second challenge to deal with, the chemistry. All the easy-to-smelt ores near the surface were long gone. Now, deep underground, they were dealing with those complex sulfide ores. So how do you get copper out of a rock that simply does not want to let it go? Their main method was pretty nasty, honestly. It was a multi-stage process. First, they'd pile up the ore into these gigantic heaps and just roast it in the open air. This would burn off the sulfur they didn't want, but it released it as a cloud of toxic sulfur dioxide gas, creating an acid-scarred wasteland for miles around. Only after this purification step could they actually smelt the remaining ore in a furnace.
But that wasn't their only trick. They also had a much more sophisticated technique, something we now call hydrometallurgy. This wasn't about fire and brute force. This was about clever chemistry, using water as a solvent to literally pull the metal right out of the rock.
I mean, just look at this process. It is absolutely remarkable. They'd let acidic water trickle through piles of low-grade ore,
the stuff that wasn't even worth smelting. That water would dissolve the copper, creating this copper-rich liquid. Then, and this is the absolute genius part, they'd pour that liquid into vats full of scrap iron. A chemical reaction would kick off where the iron atoms would literally swap places with the copper atoms in the water. This forced pure solid copper to drop out of the solution or cement out. It is one of the earliest known examples of industrial-scale chemical replacement. Just incredible.
Now, this mastery of chemistry didn't just help them get copper out of rock, it also let them create a whole new material that was super important for their money: brass, that beautiful golden-colored mix of copper and zinc. But making brass, that came with its own unique chemical puzzle. Take a look at the numbers here. Zinc boils at 907 degrees Celsius, but copper doesn't even start to melt until it's over 1,000 degrees. So if you just tried to melt them together in a pot, all the zinc would just turn into a gas and float away before the copper even got gooey. So what did the Romans do? They came up with another brilliant cementation process. They would take solid copper and seal it inside a clay pot, a crucible, with zinc ore, not pure zinc metal. When they heated it all up, the ore would release zinc as a vapor. But inside that sealed pot, the vapor had nowhere to go, so it would absorb directly into the solid copper, creating a perfect brass alloy without ever having to melt the two metals together in the traditional way. It's just so clever. So, okay, when you put all of these pieces together, the mountain-wrecking hydraulics, those underground water lifting machines, the advanced chemical processes, you start to see the true picture. This wasn't just a mine, it was an industrial machine on a truly epic scale. And this number, this one number says it all. In their time at Rio Tinto, it's estimated the Romans pulled 24 times million tons of ore out of the ground. That level of output was so massive that humanity would not see anything like it again for another 1,500 years, not until the Industrial Revolution finally kicked off. So let's just do a quick recap of the insane innovations we've talked about. To get the copper that fueled their empire, the Romans developed some incredible solutions. Ruinum montium to literally blow away mountainsides, incredibly complex water wheel systems to fight back the floods deep underground, hydrometallurgy to squeeze copper out of low-grade rock, and brass cementation to create a vital new alloy. Each and every one of them was a major technological leap.
Copper, the stuff for plumbing and pennies? But believe me, its role in literally forging the world we know today was, well, anything but common. It's a story all about power, about incredible innovation, and yeah, a whole lot of conflict.
All right, so to really get this, we've got to travel back in time. We're heading to medieval Sweden, to a specific spot called the Fallen Mine. Now, this wasn't just any old mine. It was an operation that was about to completely change the balance of power in Europe. And when I say change the balance of power, I mean it. The scale here is just wow. Think about this. By the 1600s, this one single mine was pumping out 2/3 of all the copper in Europe. 2/3! So this wasn't just some business, you know? It was a straight-up geopolitical weapon, a source of power that could make or break kingdoms. I mean, it was so incredibly important to the Swedish state. It's what funded their massive military campaigns, like during the 30 Years' War, that they literally called it the Treasury of Sweden. Let that sink in. A mine was the national treasury. This thing paid for an entire army.
So how did they even get all this copper out of the ground? Well, the method they used was just as intense as the mine itself. It was called fire setting. It sounds kind of basic, but man, it was effective. You basically build these huge bonfires right up against the rock face, get it glowing hot, and then just let it cool down super fast. That sudden temperature drop would just crack the rock apart. But you can just imagine the cost to the people doing the work, right? These tunnels would fill up with toxic smoke. It was incredibly dangerous, truly life-threatening stuff.
But what's really wild is that this mine wasn't just about raw power and brute force. It was also at the forefront of finance. Seriously, check out this date, 1288. That's the year of the first ever recorded sale of a share in the company that ran the mine. This makes its company, Stora Kopparberg, arguably the world's oldest public company. They were inventing modern capitalism way back in the 13th century, a totally revolutionary way to fund a huge project like this, a model that, basically runs the entire world today.
Okay, so that's what's happening up in Sweden, a state-controlled machine built on copper. But at the same time, down in Central Europe, a totally different kind of power was starting to bubble up. This one wasn't driven by a king or a queen. Nope, this was all about private ambition.
And for that, you need to meet the Fugger family.
Yeah, the Fuggers. They started out as weavers, believe it or not, but they became the absolute masters of the copper game. How? By building what we'd now call a vertically integrated empire. Basically, they owned the whole shebang. They didn't just sell copper, they controlled the mines, they controlled the smelters that processed it, they even controlled the trade routes to get it to market. The result? A massive, powerful monopoly. And let's be clear, this was way beyond just business. This was pure power. The head of the family, a guy named Jakob Fugger, they literally called him Jakob the Rich, used all that copper money to become the personal banker to emperors and even the Pope. I mean, his fortune was so huge, he could actually influence who became emperor and who became Pope. It's really the first time you see how a single commodity in private hands could totally shape history on a global scale. So what you've got here are two totally different, competing ideas of power popping up in Europe. On one hand, you have Sweden, where copper is this huge, state-controlled strategic resource. And on the other hand, you have the Fuggers, where copper is the fuel for a private fortune so big it could challenge governments. Two different models, but guess what? Both were built on the same exact thing: copper. And with all that incredible wealth, the Fuggers actually left behind something pretty amazing. It's called the Fuggerei. Get this, it's the world's oldest social housing project. Jakob the Rich founded it for the city's poor workers. It's this fascinating example of, a rich family taking care of the little guy. And the craziest part, it is still operating today. So the big question is, how did the Fuggers get that rich? I mean, mind-bogglingly rich. It wasn't just because they were good at business. No, they had a secret weapon, a huge technological breakthrough that let them pull a ton of hidden wealth out of their copper ore. And that secret was a clever little method called the Saker process. See, a lot of copper ore has tiny bits of valuable silver trapped inside it. The Saker process was basically a genius chemical trick for getting that silver out. And it all worked because of the simple fact that different metals behave differently when you heat them up. The science behind it is actually really cool and pretty simple. Just look at these melting points. Lead turns to liquid at a pretty low 327 degrees Celsius. Copper, on the other hand, needs to get over 1,000 degrees. And here's the kicker. For whatever chemical reason, silver would much rather hang out with lead than with copper. That little fact, that was the key to unlocking a massive fortune. So here's what they did. Step 1, they'd melt down the copper that had silver in it, and they'd mix in a bunch of lead. Step 2, they let the whole thing cool down into a solid brick or a cake. Step 3, and this is the magic part, they gently heat that cake back up, just hot enough to melt the lead but not the copper. And the lead would literally sweat out of the block, and it would drag all the precious silver along with it. What you were left with was a pure copper sponge and a puddle of silver-rich lead. Absolutely genius, and it made them unbelievably wealthy. Okay, so you've got these new ways to organize businesses and this new tech making tons and tons of copper available. Well, all that copper had one final and very explosive impact on the world. It was about to completely transform the battlefield. Back in the 15th and 16th centuries, the cannon was the new superweapon. It was the ultimate game changer. Now, you could make them out of iron, and that was cheaper. But early iron cannons had a really big problem. They were brittle. They could just explode. Not great for the guy standing next to it. But bronze cannons, and bronze is just a mix of copper and tin, they were way better. They were tougher, they didn't rust as easily, and most importantly, they would bend before they'd break. That made them way more reliable and a whole lot safer for the people firing them. So what did that mean? Well, every king and prince wanted the best cannons, which meant everyone needed bronze. This created a huge feedback loop. The massive demand for bronze cannons drove even more mining back in Sweden and in the Fuggers' territories. Suddenly, the entire copper industry was directly tied to military might and the rise of powerful modern countries.
So picture this. It's the 17th, 18th centuries. If you looked around, copper was just a part of everyday life. It wasn't fancy like gold or silver, not at all, but man, was it useful. It was absolutely everywhere.
I mean, you'd find it in your kitchen as pots and pans. The books you were reading? Yeah, those were printed using copper plates. It was even a huge deal in the colonies for these massive vats used to boil sugar. And of course, it was the metal of small change. The coins jingling in your pocket.
So that's the setup, right? An ordinary, everyday metal. Which begs the question, how on earth does something you cook with end up building an empire and inventing modern money? Well, it's a wild tale of two completely different, massive problems that demanded some pretty radical solutions. Okay, so our first story kicks off in Sweden, and let me tell you, they had this really weird economic headache. They had so much copper, it was actually becoming a huge problem.
You see, back in the mid-1600s, Sweden was basically drowning in copper but had almost no silver. Now, to keep the international price of their biggest export from totally crashing, the Swedish crown made this incredibly bold decision. They said, okay, we're going to limit exports and just turn all this extra copper into money for us to use right here at home.
The result was, well, this: plate money. And because copper is so much less valuable than silver, the coins had to be gigantic to be worth anything. Seriously, we were not talking about pocket change here, we're talking about massive rectangular slabs of metal. And just to give you an idea of the scale we're talking about, get this. A single 10-dealer coin from 1644 weighed nearly 20 kilograms. That's 44 pounds. Can you imagine trying to buy a loaf of bread with a 44-pound piece of metal?
I mean, it got so ridiculous that, as this quote from the time perfectly puts it, carrying one's wallet required a sled or a horse. Just let that sink in. You needed a horse-drawn sled just to go shopping. This whole system was, to put it mildly, completely impractical. But here's the thing. This absolutely huge problem forced a truly huge innovation. People started hauling their ridiculously heavy copper plates to the brand new Stockholm's Banco for safekeeping. And in return, the bank gave them paper receipts. Receipts that, pretty soon, people started trading instead of the actual metal. And just like that, boom. In 1661, Europe's first real banknotes were born, all because copper was just too darn heavy to carry around.
Okay, so that's how heavy money gave us paper money. Now let's jump over to our second story and see how copper's weird properties caused a completely different kind of crisis. This time, out on the high seas with the British Royal Navy.
So for any wooden navy back then, there were these two silent, relentless enemies. The first was this little guy called the shipworm, which, by the way, isn't a worm at all, it's a mollusk. And it would bore into the solid oak hulls of ships, literally turning them into something like honeycomb. The second enemy was biofouling, all the weeds and barnacles that would crust up on a ship's hull, making it super slow and clumsy in the water.
Now, the British Royal Navy had tried all sorts of fixes, but nothing was really working. So, in 1761, they decided to try something totally radical. They took an entire ship, the frigate HMS Alarm, and they basically wrapped its entire hull in a thin skin of copper plates.
And oh my gosh, the results were mind-blowing. The copper is a natural biocide, right? So it's basically poisonous to those shipworms and all the marine growth. Suddenly, a copper-bottomed ship was way faster, way more agile, and, this is the big one, it could stay out at sea for years without needing to be hauled into a dry dock for scraping and repairs. This was a massive, massive technological leap.
It seemed like the perfect solution, a total game changer. But then, a terrifying mystery started to unfold. The copper was doing its job protecting the wood, but something else was going catastrophically wrong. The actual iron bolts holding the ships together, they were just falling apart.
What the shipwrights had accidentally stumbled upon is a phenomenon we now call galvanic corrosion. Basically, when you put two different metals, in this case copper plating and iron bolts, into salt water, you accidentally create a weak electrical current. You turn your ship into a giant floating battery, a battery that was literally eating its own iron bolts. It's actually a pretty simple but totally destructive process. You've got the copper sheath and the iron bolts. The salt water connects them. An electric current starts to flow between the two metals. And the result? The iron bolts corrode away into this useless, rusty paste, threatening to just tear the entire ship apart in the middle of the ocean. The solution, which they finally figured out in the 1780s, was to stop using iron bolts entirely. They switched to bolts made from a copper-zinc alloy, basically brass or bronze, which didn't react with the copper sheathing. And with that final piece of the puzzle solved, the Royal Navy's global dominance was pretty much sealed.
So, we've got these two seemingly unrelated stories. One about ridiculously heavy money in Sweden, the other about warships falling apart at sea. So what's the connection? Well, they both show how history forged a brand new, powerful meaning for the supposedly ordinary metal. When you really look at it, both stories reveal the exact same truth. It was copper's own physical properties, its incredible weight in one case, and its weird electrical reactivity in the other, that created these massive, unexpected problems.
And the struggle to solve those problems led directly to world-changing innovations, modern banknotes, and an unbeatable navy.
And this is where our two stories connect so perfectly. That term, copper-bottomed, which was born from this incredible naval engineering breakthrough, actually entered the English language. And it came to mean something that was solid, reliable, and, how perfect is this, given our sweetest story, financially sound. A copper-bottomed investment was a sure thing.
This quote right here, it perfectly sets the stage. Just think about that for a second. Iron and steel, they gave the industrial age its bones. You know, the rails, the bridges, the machine frames. But copper? Copper was its nervous system. It was the stuff that let everything communicate, that transmitted power and information, turning all that dead metal into a humming, synchronized global machine.
So how did copper get this huge promotion to become the world's nervous system? Well, it needed a spark. And that spark, funnily enough, didn't come from a mine. It came from a laboratory, right at the dawn of the 19th century, with a discovery that was about to change, well, pretty much everything.
Say hello to the voltaic pile. Invented back in 1800 by Alessandro Volta, this thing was a total game changer. Before this, electricity was just a party trick, a fleeting spark you could capture in a jar. But Volta's simple stack of copper and zinc discs, it created the world's first ever battery, a steady, controllable electric current. And that was the exact moment copper started its journey from being just a metal for pots and pans into a material that was absolutely essential for science. And this one invention kicked off an unbelievable chain reaction. Suddenly, with a steady current to play with, scientists made one breakthrough after another. In 1820, a simple copper wire proved the link between electricity and magnetism. Just 5 years later, someone wrapped that copper wire around a piece of iron, and boom, the first electromagnet, the heart of basically every motor to come. And then in 1831, Michael Faraday's spinning copper disc proved you could turn motion into electricity. All of a sudden, copper wire was the key to unlocking the fundamental secrets of the universe.
Okay, so with this brand new scientific demand, the world needed a lot of copper, and it needed a reliable supply. And for a while, pretty much everyone turned to one very specific corner of the world to get it.
Welcome to Cornwall, England. Seriously, in the early 19th century, this windswept peninsula was basically the Silicon Valley of mining. They had this amazing new tech, powerful steam engines that could pump water out of super deep mine shafts. This let them get to these incredibly rich, high-grade veins of copper that no one else could touch. For a good while, this one tiny region was pumping out the vast majority of the world's copper ore. But Cornwall had a problem, a critical weakness, really. A kind of logistical paradox that opened the door for an industrial partner just a short trip across the water. And here's the puzzle. Cornwall had all this amazing copper ore, but almost zero coal to smelt it with. Meanwhile, over in Swansea, Wales, they were practically sitting on mountains of coal, but had no copper of their own. So what do you do? Well, the answer was simple. It was way, way cheaper to ship the heavy ore to the fuel, not the other way around. And just like that, you had this perfect and very profitable partnership.
The result was just staggering. By the 1840s, the city of Swansea in Wales was producing over 40% of the entire world's refined copper. I mean, think about that. It rightly earned its nickname, Copperopolis, the undisputed global capital of copper. Now, their secret weapon was something called the Welsh method of smelting. It was this super complex, multi-stage process, and they guarded it like an industrial secret. This expertise was so concentrated in Swansea that it created this kind of gravitational pull on the whole market. It didn't matter where you found copper ore in the world. You sent it to Wales to get processed. But here's the twist in the story. Swansea's incredible success, ironically, ended up planting the seeds of its own partner's collapse.
You see, the Welsh furnaces had an absolutely insatiable appetite for ore. As Cornwall's mines started to struggle to keep up, the copper barons of Swansea began financing mining operations all over the planet, from Cuba all the way to Chile. They were basically creating the world's first truly globalized heavy industry supply chain, all just to feed their hungry smelters.
And this is right where the whole story flips on its head. In their global hunt for more ore, the Welsh smelters also exported their technology. In the 1830s, their advanced furnaces showed up in Chile, which let the Chileans cheaply process their own awesome, high-grade ore. By the 1840s, all this new, cheaper copper started flooding the market. And by the 1850s, the game was over.
Chile had officially blown past Cornwall, and the center of the copper world had jumped clear across the globe. So as you can imagine, this global shift had a devastating impact back in Cornwall. It led to economic collapse and just massive social upheaval.
Which brings up a really interesting question. As all of its mines started shutting down, what happened to the people who were, without a doubt, the best and most experienced miners on Earth? Did all of that unique, hard-won expertise just disappear?
No, not at all. They became known as Cousin Jacks. It was this affectionate nickname for the expert Cornish miners who started this massive exodus from their home, all looking for work. But here's the key. They didn't just leave with their luggage. They carried an entire culture of technical knowledge with them.
And these guys went everywhere. The Cornish diaspora took their incredible hard rock mining expertise to the new copper fields in Michigan, to the brutal deserts of Australia, and high up into the mountains of South America. So, in a strange way, Cornwall's economic loss became the whole world's technological gain.
And this is their real, enduring legacy. Even while Cornwall's physical production just faded away, its methods, its steam engine technology, even its unique mining slang became the global standard for the entire industry. Their influence lasted way, way longer than their own mines ever did.
In the late 19th century, though, this simple reddish-brown metal became everything. It was the physical backbone of the modern world, the wire that was literally going to carry all of our biggest dreams.
And it really all kicks off right here. It's 1844, and Samuel Morse taps out this very message on a copper wire strung between Washington, D.C. and Baltimore. Now think about that. For the very first time in human history, a complex idea travels faster than any horse, any train, anything. That one moment ignites this absolutely insatiable global demand for copper wire.
And just like that, the race was on. A race to build what you could only call the world's nervous system. Moore's message started this monumental project to literally wire up the entire planet, and copper was right at the heart of it all.
But the biggest challenge wasn't going to be on land. No, it was bridging an entire ocean of silence. The ultimate prize was a 2,000-mile-long telegraph cable stretched across the Atlantic. This was the absolute moonshot of its day.
And at first, it was a spectacular failure. I mean, after years of unbelievable effort and just immense cost, they finally laid the 1858 cable. It worked for a second. And then, after just a few weeks, it went completely silent. The world's brand new nervous system had a total catastrophic breakdown.
So what on earth went wrong? Was the whole idea just flawed? Not at all. The failure wasn't in the concept. That was brilliant. It was all in the execution. And it really came down to a fundamental, and frankly, a disastrous misunderstanding of the physics involved.
And this table just lays it all out, the difference between failure and success. The first guy, Chief Electrician Edward Whitehouse, he tried to fix a weak signal with pure brute force. He blasted it with 2,000 volts. Well, I just completely fried the rubber-like insulation. 8 years later, they listened to the science, guided by Lord Kelvin. They used higher purity copper and a much, much lower voltage. They respected the physics, and the result, a permanent link that absolutely changed the world.
Okay, so with the network expanding across continents, a totally new problem popped up. The wire itself was just too fragile. See, pure copper is an amazing conductor, but it's also really soft. The wires were literally stretching and snapping under their own weight. The network needed to get tougher.
The solution was this really clever bit of metallurgy. In 1877, a guy named Thomas Doolittle perfected what's called hard-drawn copper. By pulling the metal through these special dies, he massively increased its tensile strength, that's its ability to resist stretching, without really hurting its conductivity. All of a sudden, we had a wire that was both super strong and a fantastic conductor.
And this is just a perfect example of how innovation builds on itself. This stronger wire showed up at the exact right moment. Why? Because just a year earlier, in 1876, Alexander Graham Bell had invented the telephone. Now, a telegraph's simple clicks could get by on an old iron wire, but the complex, subtle signals of a human voice? No way. That needed the superior fidelity that only copper could give. Hard-drawn copper is what made the long-distance telephone network a reality.
Now let's jump to the next phase, because this is where it gets really interesting. Just as the communication network was getting solid, an even hungrier consumer for copper showed up, the electric power grid. And this set the stage for one of the greatest tech battles of the century, the War of the Currents. So on one side, you've got Thomas Edison, and he's championing direct current, or DC. It was revolutionary for sure, but it had this one killer flaw. It couldn't travel very far. You basically needed a power station within a mile of every single customer. On the other side, you've got George Westinghouse and Nikola Tesla with alternating current, or AC. Using this amazing copper wound device called a transformer, AC could be sent over huge distances. That meant fewer, bigger, and way more efficient power plants. To really get a handle on Edison's DC problem, just look at this number. His very first power station on Pearl Street in Manhattan needed over 80,000 feet of thick, expensive copper wire just to power one single square mile. It was a massive economic bottleneck. The price of copper itself was holding back the entire electric age.
In the end, AC's efficiency won the war. But here's the wild paradox. Even though AC was more efficient and used less copper per mile, its victory made electrifying everything so cheap and easy that the total demand for copper just exploded. Every factory, every new house, every streetcar, every single electric motor needed copper windings and copper wires.
And this created the next massive crisis. The world had wired itself for talking and was now wiring itself for power. And in the process, we'd pretty much burned through all the world's known high-grade copper deposits. The entire electrical age was staring down a supply cliff. The rich veins were just running dry.
The answer came from a place nobody was even looking. For decades, miners knew about these huge rock formations called porphyry deposits, but they just ignored them. Why? Because the copper was spread out in tiny, tiny amounts, often less than 2%. To them, it was just worthless garbage rock. So the big breakthrough wasn't finding a new, richer mine. It was a completely radical shift in thinking. In 1893, a couple of engineers looking at places like Bingham Canyon, Utah, proposed something that sounded totally nuts. Stop hunting for the rich veins. Instead, let's just mine all the low-grade rock, but do it on an absolutely unbelievable scale.
They basically applied factory manufacturing logic to mining a mountain. Instead of digging tunnels, they decided to just remove the whole mountain. That's open pit mining. They'd use these gigantic steam shovels and fleets of railroad cars to move millions of tons of rock to huge processing plants that could concentrate those tiny little flecks of copper. It was a massive bet on economies of scale.
And you know what? It worked, big time. When the Utah Copper Company got going in 1906, it kicked off the Porphyry Revolution. They proved that mining this low-grade rock in bulk wasn't just possible, it was wildly profitable. This one shift in strategy unlocked billions of tons of copper that were previously considered untouchable, securing the supply for the rest of the electrical age. So when you look at this timeline, you see this incredible story of cascading innovations. It's amazing. At each step, a new problem popped up. Distance, strength, cost, supply, and each and every time, a breakthrough that involved copper came along and provided the solution, pushing the modern world forward. Today, we're going to dig into the incredible story of copper in the first half of the 20th century and find out how it got this amazing nickname, the metal with a PhD. It's a weird question, isn't it? I mean, how does a simple metal, something we just dig out of the ground, end up with an advanced degree in economics? Well, it's because copper earned this special reputation, a nickname that economists and traders still rely on to this day. To get how that happened, we first need to know the nickname itself. So meet Dr. Copper. The idea is actually pretty simple. A change in its price can be a huge signal of a coming boom or a bust for the whole economy. And this reputation? It was forged in the fire and fury of the early 20th century.
Okay, Section 1, The Great War's Metal. Our story really kicks off in 1914. Before this, copper was, well, it was just a commodity. But the start of World War I was about to change everything, transforming it into a strategic weapon, something absolutely essential for a nation's survival.
The war was a whole new kind of terrifying. People called it industrialized slaughter. And the real key to it all wasn't just the guns themselves, but the tiny metal casings that held the bullets.
The physics here is actually fascinating. So those cartridges were made of brass. That's a mix of copper and zinc. And brass has this really unique property. When it's fired, it expands just enough to perfectly seal the chamber, trapping all the gas. Then, a split second later, it contracts just enough so the empty casing can be ejected smoothly.
That precise little dance is what made rapid-fire machine guns and modern artillery possible. And just like that, the demand for copper exploded. Armies needed millions upon millions of shell casings, thousands of miles of telephone wire for their battlefield communications, and critical parts for all their naval ships. The Allied powers were desperate for it, and they all turned to the world's biggest producer at the time, the United States. And as you can guess, prices just skyrocketed.
Section 2. Boom, bust, repeat. The years between the wars were a total wild ride for copper. After the war ended in 1918, the market was suddenly flooded with surplus metal and prices crashed hard. But that didn't last long, because a brand new wave of civilian demand was about to kick off one of the biggest economic booms in all of history.
Check out this number. By 1925, an incredible 50% of all homes in the United States were wired for electricity. Just think about that for a second. An entire country was plugging in for the very first time, and every single one of those connections needed copper wire.
And this chart really shows where all that copper was going. Yeah, electrification was the biggest piece of the pie, but it set off a chain reaction. See, once you have power, you need stuff to plug into it. Radios, washing machines, refrigerators, and of course the auto industry was booming, and every car needed copper for its radiator and all its electrical system.
So the 1920s roared, and they roared on a river of copper. But then came 1929. The party came to a screeching halt. The Great Depression absolutely devastated the industry. As factories closed and construction just stopped, the demand for copper pretty much vanished overnight.
The price collapse was staggering. I mean, it fell so low that it was actually cheaper to buy copper on the open market than it was for even the best mines to dig it out of the ground. So, what happened? Mines across the country just closed up shop.
Now here's the crucial point. Copper's price didn't just fall during the Depression, its sharp drop as orders dried up actually predicted how bad the collapse was going to be. It was this insane boom and bust cycle that really cemented its reputation. Dr. Copper was officially born.
Section 3. The war's secret ingredient. So as the world plunged back into war, the demand for strategic materials got even more intense than the first time around. Copper was once again a critical piece of the war machine, and the US government started taking some really extraordinary steps to get every ounce it could.
Here's a perfect example. In 1943, the US Mint actually switched to making pennies out of zinc-coated steel. Why? To save that tiny bit of copper from every single coin for the war effort. Every little bit counted. But while the government was literally pinching pennies, it was also making a much, much bigger substitution.
This is one of the most incredible, little-known stories of the war. To solve a critical copper shortage for a top-secret project, the US Treasury loaned out something way more valuable, almost 15,000 tons of silver. And what was that top-secret project? It was the Manhattan Project. They needed a massive amount of highly conductive metal to build these gigantic electromagnets to separate uranium isotopes down at Oak Ridge, Tennessee. The best metal for that job was copper, but there just wasn't enough to spare. So in this amazing move of strategic substitution, they used the next best thing. Actually, the only thing better: silver, straight from the US Treasury vaults.
Section 4. Forging the post-war world. Okay, so after the war, the world started to rebuild, which kicked off yet another period of just unbelievable economic expansion. And just like it was in the 1920s, copper was right there at the center of the boom.
The demand was now totally global. You had the Marshall Plan rebuilding Europe, Japan's entire economy being rebuilt from the ground up, and back in the US, a massive post-war housing boom was creating suburbs everywhere. All of it required huge amounts of copper for new infrastructure, wiring, and manufacturing.
And this is where the story comes right into our own homes. Seriously, if you live in a house built after the 1950s, your water pipes are probably made of copper. Before that, pipes were often galvanized steel, which would rust, or even lead, which we now know is incredibly toxic. Copper tubing was durable, easy to work with, and it didn't corrode. It became the new gold standard for modern plumbing. This enormous global demand also started to shift the geopolitical map of copper. For a long time, the US was the king of copper production, but now that started to change as nations turned to the incredibly rich deposits in the African copper belt in what is now Zambia and the Congo. These regions suddenly became crucial players in the global supply chain. You know, in just 30 years, from 1960 to 1990, the entire world of copper got turned completely upside down. But this wasn't just one single event. It's really a story of two massive competing revolutions.
One was this huge political firestorm, fought out in the halls of government, and the other, a super quiet breakthrough, perfected in the labs of engineers.
And at the heart of that first revolution was this really fundamental question: who should own the wealth that's literally under the ground? For generations, corporations had the answer to that. But in the 1960s, a new, really defiant voice started to rise up from the nations themselves. And boy, was it about to ignite a firestorm in the copper industry.
So here's the game plan for this explainer. First, we're going to look at that old world order and the political uprising against it, from taking over the mines to a pretty spectacular failure at building a cartel. Then we'll pivot to the quiet tech breakthrough that, in the end, reshaped the entire cost of making copper.
Okay, so what was this old world order that was about to get completely shattered? Well, before the 1960s, the copper industry was, without a doubt, a world run by giants.
Basically, you had a handful of incredibly powerful Western multinational corporations, and they controlled the mineral wealth of entire developing nations. We're talking about giants like Anaconda in Chile and Union Miniere in the Congo. They commanded the world's richest copper deposits, and you can guess where the profits went. The vast majority flowed right out of the countries where the ore was actually mined.
But a system like that, well, it was living on borrowed time. As this wave of decolonization and anti-imperialist feeling grew and grew, just holding on to another nation's resources became, frankly, politically impossible. The stage was set for a pretty dramatic reclamation.
And Chile was really the poster child for this whole movement. Just look at how fast things escalated. It started off kind of gradually in the mid-60s with a policy called Chileanization, where the state just bought a 51% majority stake. But then, in 1970, the election of the socialist Salvador Allende, well, he threw gradualism right out the window. By July of '71, the Chilean Congress voted unanimously to fully expropriate, or basically seize, all the remaining assets from the US copper giants.
And this quote, wow, it just says it all, doesn't it? Allende didn't call it the day of economic strategy. He called it the day of national dignity. For Chile, this was about so much more than just money. It was this profound statement of sovereignty, of self-respect. The result of all this was the creation of Codelco, a huge, state-owned copper corporation that brought all these world-class mines under one roof. And hey, this wasn't just a Chile thing. Similar stuff was happening all across Africa, with the Congo and Zambia also nationalizing their huge copper industries. The era of corporate control was over. The era of state control had officially begun.
Okay, so now the world's biggest copper reserves are in the hands of these sovereign states. What's the next logical move? They start thinking, hey, if we control the supply, maybe we can control the price. And they looked over to the oil world for a little inspiration.
The model they tried to copy, of course, was OPEC. Back in 1973, the oil cartel shocked the entire world by quadrupling prices. So the major copper nations, we're talking Chile, Peru, Zambia, and Zaire, they formed their own version called CPEC to do the exact same thing. But, as you can see here, the result was, very, very different.
So why did the copper cartel fail so spectacularly? Well, it really comes down to the metal itself. See, you burn oil, and it's gone. But copper, it's incredibly durable and it's highly recyclable. The moment CPEC tried to jack up prices, bam, a massive flood of existing scrap copper hit the market, completely undercutting them. On top of that, these countries were so dependent on copper money they just couldn't afford to cut production. In fact, when prices fell, they often pumped out more copper just to keep the cash flowing, which, just made the whole problem even worse.
So the political revolution had kind of run its course. Ownership changed, for sure, but the big attempt to control prices had flopped. And as the 1980s started, a whole new crisis was brewing, one that politics just couldn't solve. This was going to require a totally different kind of revolution.
The problem was really a double whammy. Global copper prices were stuck in a slump, and after decades and decades of mining, all the rich, easy-to-get-to ore was pretty much gone. Miners were having to dig up more and more rock just to get the same amount of copper, and that sent costs through the roof. The industry desperately needed a hero.
And that hero arrived in the form of a really complex-sounding process called solvent extraction and electrowinning, or just SXEW. Now, the magic of this technology was its ability to pull incredibly pure copper from stuff that everyone thought was garbage, low-grade ores and old waste dumps that were totally worthless to traditional smelters.
So how on earth does it work? Well, it's basically a three-step chemical dance. First, a process called leaching uses acid to dissolve the copper from the ore into a liquid. Second, in extraction, a special solvent acts like a chemical magnet, pulling only the pure copper out of that liquid. And finally, electrowinning uses an electrical current to plate that pure copper onto metal sheets. And here's the real kicker. This whole process completely bypasses the need for massive, super expensive, energy-guzzling smelters.
Now, you have to understand, this wasn't just some minor improvement. This technological leap forward would have absolutely dramatic, industry-altering consequences on the whole economics of copper.
So just how big was the impact? Billions, with a B. Billions of tons. That's how much old waste rock, stuff that was previously just a worthless liability, was sitting at mines in the US and Chile. All of a sudden, SXEW technology turned those mountains of garbage into a highly profitable asset. I mean, it's like discovering a multi-billion-dollar treasure chest in your own backyard.
And this chart just lays it out perfectly. SXEW fundamentally shattered the old cost structure of the industry. It allowed producers to make super high-purity copper for just a fraction of the cost of traditional mining and smelting. It created this whole new class of low-cost operations.
So the ultimate effect here was profound. Just as that political revolution tried, and failed, to push prices up, this quiet technological revolution acted as a massive force pushing costs down. It didn't just make copper cheaper, it totally changed the economics of mining itself. It made more copper available more cheaply than ever before, extending the lives of old mines and completely redrawing the map of who could produce copper profitably.
So let's just start with a question. What on earth could the tiny phone in your pocket have in common with the single biggest construction project in all of human history? Well, the answer's copper, but the how and the why, that's where things get really interesting. It's a story about microscopic engineering and massive geopolitical power shifts, and it all happened at once, shaping, well, pretty much everything around us today. All right, so our first story kicks off in the late 1990s, deep inside the most complicated things we've ever built, semiconductor chips. The digital age was just hitting its stride, but it was about to slam into a very real, very hot physical wall. See, for decades, engineers were stuck in a dilemma. The tiny, microscopic wires inside chips were made of aluminum. It worked, it was easy, and most importantly, it didn't mess with the delicate silicon. But as chips got smaller and faster, aluminum's high electrical resistance was becoming a huge problem. It was like trying to push a river through a garden hose. It was just generating way too much heat. The obvious solution was copper. It's about 40% more conductive, but it had this one fatal flaw. To silicon, copper is pure poison. It literally seeps into the transistors and just kills the chip.
So you can see the problem, right? The entire forward march of computing, the thing we all know as Moore's Law, was grinding to a halt. The very engine of the modern world was on the verge of overheating and slowing down, all because of this one little materials science problem.
The whole industry needed a breakthrough, and it came from a team that figured out how to solve this impossible chemistry problem, unleashing a new wave of innovation.
The year was 1997, and a team of researchers at IBM totally cracked the code. They announced a solution that had stumped the entire industry for years. They called it the dual Damascene process. And the absolute genius of it was that they just reversed the logic. Instead of trying to lay copper wires on top of a chip, they decided to build the chip around the copper.
It was this brilliant three-step dance. First, you etch these tiny trenches right into the chip's insulating layer. Basically, you carve out the paths where you want the wires to go. Then, and this was the absolute game changer, they figured out how to coat those trenches with an impossibly thin barrier material. This little liner would safely contain the copper. And then finally, you could just fill those protected channels with all the superconductive copper you wanted. The poison was caged and its power was finally unleashed.
And the impact was, it was immediate and it was profound. This single innovation gave us faster, cooler, smaller processors. It's what directly fueled the explosion of the internet age in the early 2000s. And a few years after that, it's what made the power and efficiency of the modern smartphone possible. And why this matters is simple. That device you have in your pocket right now exists thanks to this tiny microscopic breakthrough.
Okay, but here's where the story takes a huge turn. At the exact same time that copper was letting us build smaller, faster worlds inside our phones, it was also being used to build a brand new world on a scale nobody had ever seen before. And this brings us to our second copper story.
Let's go back to the year 2000. Back then, China was a pretty small player in the copper game. They used just 12% of the world's supply.
But then, after China joined the World Trade Organization in 2001, something absolutely unbelievable happened.
By 2014, in just a little over a decade, China's appetite for copper had skyrocketed. They were consuming nearly half of the entire planet's supply.
This incredible surge in demand created what economists call a commodities supercycle. So what was driving it? Well, it was three gigantic things happening all at once. The largest movement of people from the countryside to cities in history, building a massive new national electrical grid from scratch, and of course, China becoming the factory for the entire world. All of it needed unimaginable amounts of copper.
But here's the thing. China's ambition was much, much bigger than just buying up copper. The real strategy wasn't just to consume the metal. It was to control a critical bottleneck in how it's produced.
So, this is the crucial part. China knew it didn't really have enough copper mines of its own, so they basically let other countries do the hard work of digging it out of the ground. They started importing enormous quantities of raw, unprocessed copper ore, it's called concentrate, from places like Chile, Peru, and Australia. And then they poured billions into building the world's biggest and most advanced network of smelters and refineries.
You know, as one source put it, China became the world's furnace. It was the one place where all this raw material from all over the globe was being sent to be turned into the pure metal that the global economy runs on.
And the result of that strategy is, well, it's a staggering level of control. Today, China commands 45% of the entire world's copper refining capacity. It just goes to show you, you don't have to own the mines to have immense power over the supply chain. What this deliberate strategy did was create a massive strategic choke point. Almost every country, whether they're building electric cars, wind turbines, or data centers, is now reliant on China's industrial machine to get the finished, usable copper that they need.
So let's bring our two stories together now. You've got the micro revolution happening inside our computer chips and the macro revolution happening in global industry. Both were powered by copper, and both led to this really profound shift in who holds the power. And this, right here, this is the new reality. For 100 years, the center of the copper world was in the financial hubs of London and New York. That's who controlled the big mining companies and the money. Today, that center of power has decisively shifted east. It's now in the hands of state planners in Beijing who control the refining and, crucially, the world's biggest source of demand.
Okay, so we're all talking about wind turbines, solar panels, and electric cars these days. But what if I told you that behind this entire green revolution, there's a hidden engine, an ancient metal that's suddenly become one of the most critical resources on the entire planet?
That's right, copper. Good old-fashioned copper. It's the unsung hero, the circulatory system of this whole energy transition. And we're going to need an absolutely mind-boggling amount of it. So in this explainer, we're going to break down exactly why. Okay, so first things first, let's get into why copper is just so essential. As the world electrifies everything, the demand for this metal is set to just explode. Why? Well, it's pretty simple. Copper is the most cost-effective conductor of electricity we have, period. That makes it the bedrock, the foundation of all green technology. And that leads us to something analysts are calling the green demand shock. The key thing to understand here is that green systems don't just use copper, they are jam-packed with way more of it than the fossil fuel technologies they're replacing. It's a completely different level of intensity. The difference is just stark, especially when you look at cars. Your standard gas-powered car has about 23 kilograms of copper in it. A battery electric vehicle, it needs around 83 kilograms. We're talking nearly 4 times the amount of copper for a single car. So you might be wondering, where is all that extra copper going? Well, it's pretty much everywhere inside an EV. It's the foil in the battery anode, it's wound super tightly inside the electric motor, it's all over the inverter that manages the power, and of course, it's in all that heavy-duty cabling that connects the whole system together. And hey, this demand shock isn't just about cars. Let's talk power generation, because this is where the numbers get really big. A wind turbine is basically a giant generator that needs literal tons of copper. On average, wind and solar power require 3 to 5 tons of copper for every single megawatt of capacity. That absolutely dwarfs the amount of copper needed for fossil fuel generation. It's not even in the same league. And get this, it doesn't even stop there. Beyond the cars and the power plants, we have to build out the entire support system for them. Every single home charger, every public charging station. That adds yet another massive layer of copper demand on top of everything else. So, all this exploding demand obviously raises a huge question. Where in the world is all this new copper going to come from? And the answer is actually forcing the entire mining industry into new frontiers, completely redrawing the global supply map as we speak.
This right here illustrates the massive shift that's underway. For decades, Chile was the king of copper, but its old mines are now facing declining ore grades. That's the concentration of copper in the rock, often below 0.6%. Now compare that to the new frontier in the Democratic Republic of Congo, where miners are finding these incredible deposits that exceed 5% copper. That's not just a little better, that is a whole different ballgame geologically.
And look, this isn't an exaggeration. The DRC is now widely seen as the most critical new source of copper for the entire energy transition, and that's despite all the significant political and logistical challenges of operating there. The Kamoa-Kakula mine is the perfect example of this. It only started producing copper in 2021. In just 3 years, it went through this absolutely unprecedented ramp-up to become one of the largest and highest-grade copper mining complexes anywhere on Earth. The speed of that scale-up is just staggering.
And the impact of this new production? Well, it's been dramatic. Thanks to mines like Kamoa-Kakula, the DRC has surged right past Peru to become the world's #2 copper producer, second only to Chile. This really highlights just how dependent the world is quickly becoming on the African copper belt.
So you've got this new reality, soaring demand being met by supply from politically very complex regions. And that has forced governments, especially in the West, to have a major awakening. They've started to see this common everyday metal in a totally new light, as a matter of national security. The real pivot point, the moment everything changed, it was 2023. That was the year the official perception of copper fundamentally shifted.
In 2023, the U.S. Department of Energy officially added copper to its list of critical materials. This was called a watershed moment. It was the U.S. government formally admitting that any disruption to the copper supply chain was a direct threat, not just to clean energy goals, but to national security itself.
So what does this critical material label actually mean? Well, it's a formal designation for any non-fuel material that is absolutely vital for the economy or for national security, but, and this is the key part, its supply chain is vulnerable to being disrupted. Copper now fits that description perfectly. And this designation isn't just for show. It has major real-world consequences. For starters, it unlocks access to huge federal subsidies and financing, like the money in the Inflation Reduction Act. It also signals a big shift, a return to industrial policy, where the government is actively working to de-risk and secure these vital supply chains.
When you boil it all down, the ultimate goal of this whole policy shift is geopolitical. It's a strategic attempt to lessen the West's dependence on politically volatile regions for mining the raw ore, and just as importantly, on China, which right now completely dominates the global processing and refining of that copper. We're looking at a massive impending demand for copper that is completely unlike anything we have ever seen before. The sheer scale of what's being forecasted here is just stunning. Top analysts are projecting that global copper demand is going to double, not just go up a little bit, double, from about 25 million metric tons today to a staggering 50 million by 2040. This isn't just some small market shift, it's a fundamental reshaping of the entire global supply chain. So what on earth is driving this? Well, this demand surge is really coming from 3 major forces that are all happening at once. First, electrification. That means way more EVs, more wind turbines, and a huge expansion of the electrical grid itself. Second, you've got urbanization, especially in fast-growing economies in India and Southeast Asia that are building out cities and infrastructure like crazy. And the new player on the scene, AI data centers. These things require enormous amounts of copper just to power and cool themselves. Okay, so if we need more copper, the obvious question is, why don't we just, mine more? Well, that's where the other half of this problem kicks in. The supply side is facing a serious crisis of its own. To put it simply, all the easy copper is gone. The quality of the ore that we're pulling out of the ground has dropped by about 40% since 1990. Now, what that means is we have to mine, crush, and process way more rock just to get the same amount of metal. And that drives up costs like you wouldn't believe and uses a ton more energy and water. And that problem is compounded by an incredible time crunch. Get this, even if we discovered a massive, perfect new copper deposit today, the average time it takes to get permits, secure financing, and actually builds the mine is nearly 17 years. So a decision we make right now won't give us any new copper until the late 2030s.
So when you map that projected demand against our projected supply, the result is, well, it's this. A massive, basically unavoidable gap between what we need and what we can possibly produce. This right here is the coming copper deficit. By 2040, that supply gap is projected to be as big as 10 million metric tons every single year. Just let that number sink in for a second. 10 million tons. To try and put that into perspective, a 10 million ton deficit is the same as the entire annual copper production of the world's top producers. We're talking China, the United States, and Peru, all put together. We would literally need to find and build their entire mining industries from scratch just to fill that gap. Okay, so this is a monumental challenge, right? So how do we even begin to forge a path forward and bridge this enormous 10 million ton gap? Well, the solution isn't going to be some single silver bullet. It's got to be a combination of strategies. Experts have laid out 4 key paths we pretty much have to pursue all at the same time. We need to seriously ramp up recycling, which some people call urban mining. We have to explore new land-based frontiers. We might even have to look at the very controversial potential of the deep sea. And finally, we just have to substitute other materials wherever we can. So first up, this idea of urban mining. See, unlike fossil fuels, copper isn't consumed when we use it. The copper wire in an old building or a junked car is still perfectly good metal. And this process of reclaiming copper from our cities and our waste is so important because copper is infinitely recyclable. But for this to make a real dent in the problem, we need a massive scaling up. Projections show that our recycled copper supply has to more than double, from about 4 million tons a year to over 10 million tons by 2040. If we could do that, this alone could close the entire projected deficit. Now, at the same time, of course, the search for new mines is pushing into more and more challenging territories. The huge Reko Diq project in Pakistan is a perfect example. Its success or its failure is really going to be a major test of whether the world can develop these critical resources in geopolitically complex places. And then there's the wild card, deep sea mining. The ocean floor is literally scattered with these nodules that are super rich in copper and other critical minerals. We're talking reserves that could potentially dwarf everything we have on land. The catch? The environmental consequences are largely unknown, which makes this an intensely debated, really uncertain source for the future. And finally, there's substitution. Look, when copper prices get too high, simple economics forces a shift. Aluminum, for example, is cheaper and lighter, but it's only about 60% as conductive. So it becomes a viable option for things like power cables. It's not a perfect replacement. You can't build an EV motor out of it, but it acts as a really necessary pressure release valve for the market. So when you put all of this together, it becomes incredibly clear that copper's role in the world is changing. And it's changing fundamentally. It's just not another commodity anymore. You know, from the telegraph back in the 19th century to the electrical grid in the 20th, copper has truly been the red thread connecting all the great technological leaps in human history. And now it's poised to define the 21st century through the energy transition and AI. If there is one statistic that just perfectly captures the unbelievable scale of this challenge, it's this one. To meet our climate and our technology goals, the world needs to produce more copper in the next 25 years than has been produced in all of human history combined. What this all boils down to is that the era of cheap, easily accessible copper is, for all intents and purposes, over. We are now entering a totally new era, the era of strategic copper. We're just securing a stable supply as a matter of national and economic security. Which leaves all of us with one final and really critical question. The future that we all want, one that is sustainable, one that is electrified and intelligent, it has a price tag. And that price is written in copper. The real question is, are we truly ready to pay it?